Hi, welcome to our first webinar of the session of the webinars that we're gonna have this year. Through this whole year, we're gonna have the same setting that we're seeing right now, dealing with different aspects of a laser weld, mainly about IPG light weld. So to start with, I would like to ask you if you have any questions. Please put your questions here on the form that you have, and then our technical team, they can pass through me the questions that you may have, and then we can cover on this webinar. So the first thing, the webinar will be about laser penetration. Okay, this is the main issue we have with laser weld, because laser weld is a different mode of welding, is a different type of welding, and we need to understand how laser weld works, how the penetration works, and why this is something so important when we talk about laser weld. Of course, this is also important in the other type of welding, like TIG welding, MIG welding, but it's crucial when you talk about laser welding. On this webinar today, we're going to cover the mistakes that people may have, or things that you don't know that you should aim for it. We're going to understand how important is the penetration for structural integrity of the weld, and also how it can affect the aesthetic of the weld. Okay? At the end of this webinar, I hope you can take the most of it, and you can also take the most of your light weld unit or your machine to have better precision, better results. This is what we are working towards, to help you all to take the most of your equipment. This is the first session. We're going to have more sessions during the year. The next one will be very special too, so we encourage you to stay tuned to our website, to our email list, and then you can be part of it to get the most of your machine. Okay? So to start with this webinar, I would like to introduce you to the study that we are showing today. The study was conducted by IPG engineer Sergey Novikov, and it is about the impact of the light weld XR parameters on the penetration depth. This was a study made this year for the light weld. Now, one thing that I would like to tell you first is that we are talking about the light weld XR on this presentation, but the same idea can apply. We can apply the same study for all the other models of light weld. Maybe you have a different model of machine, but the principle will be the same. Currently, we have 5 different models of machine. We start with the new release, the 1000 light weld 1000. Then we have the 1500 standard machine, the XC, the XR, and the 2000 XR. What is the difference between each of the machine? It's not only the amount of power. We need to understand that the laser on the machines, they are also different. The spot size that we have, how the laser is focused is different between each machines. That's why sometimes you can see a 1500 that can have the same amount of penetration that the 1000 machine. How is that possible? Because the laser is different. Okay? So doesn't matter which machine you have on your shop right now, the idea that we're seeing in this webinar here will be the same. We can cover a large variety of metals with light weld with different depth of penetration according to the material that you're dealing with. We can start, let's say we can go maximum to 4 millimeters in an XC welding mild steel or stainless, to 8 millimeters with the 2000 machine welding aluminum 5000 or stainless. So this study that we are considering here today was presented by IPG and was based on the XR machine. This is the current setup that we're going to see the macros. I'm going to show you here different macros and how we can adapt the depth of penetration, or even how the penetration is inside the material. So we're gonna see the macros and understand how the laser penetrate in the material and how we can control that. So the setup is the light weld XR with a torch angle of 55 degrees. So what is 55 degrees? How the operator knows that he's using the right angle to weld. So laser weld it's very important when you talk about laser weld to keep the right angle when welding. And to help us, I have this rule. If you look the head of your light weld, you're gonna see that you have this line here on the handle of the head, right? So ideally, you should try to keep this line parallel to the part that you are welding. So if you're welding on a horizontal position, you would like to have the head on this position, parallel this line, parallel to the part that you are welding. This way, we're gonna have the good angle of 55 degrees. This is just a rule that helps the operator understand how to keep the right angle. I know that in a realistic world, it's not easy sometimes. When you're welding something rounded, let's say, you need to follow the angle. You need to keep the angle all the way, right? Because it's so important. If you're not having the same amount of penetration welding, let's say, a pipe or a circular piece, probably is because you are changing angles, right? So this is the first thing, the angle. This is very important to keep in mind. And then we have the programs that we use on the study was the A1 and A2 according to the chart. If you have a light weld, you're familiar with the recipe card that we have. So the recipe card, we have all the settings to weld from fusion to wire welding. On this study, we use A1, that is fusion for stainless steel, and A2, that is wire welding for stainless as well. We weld the two settings, having a base of 500 watts on fusion and 650 watts for wire welding. The wire that we used is the 045 308 stainless. And the speed changes a little bit, the traveling speed. 19 inches per minute if we're on fusion, and 14 inches per minute when we add the filler, we add the wire. And the joint was a bead on plate. Okay, so it was just a bead on a plate because what we wanted to see is the shape of penetration inside the material. The base plate was stainless 304 with a 3 millimeters of thickness, 11 gauge. Now, this is the main issue that we have when someone says that the laser weld is not strong enough or it doesn't compare with MIG or TIG. If that's happening to you, it's probably because the angle, the weld angle, or the adjustments on the machine are not proper. Here on the side, you have on the presentation the drawing. On this side, on top, you have the indication on where is the strength of MIG and TIG, let's say. So you see here that on MIG and TIG, this is the amount of penetration that we have inside the material, and this outside is the amount of material that we are adding. And then you can see that the strength of the weld is this measure here. You can imagine, if you're familiar to MIG or TIG, if you just run a small bead of TIG or MIG, you don't have strength and it's not strong enough because it's not larger enough, so you have no strength there. But laser weld is different. It's hard to have a really big bead like this. It's not large like TIG or MIG, the welding bead. It's very narrow. So how can we have the same strength? It's because of the angle. Or laser weld, it can penetrate deeper than the other procedures. That's why if you have a good angle, like in this case here, if we have the torch pointing towards the joint, we can have penetration all the way in, and then we're gonna have the same strength than the other procedures. But let's say the angle is not correct. Let's say I'm welding a little bit up with the head pointing a little bit up. The laser is gonna replicate that angle, and then I'm gonna shoot the laser just on the base plate, not hitting the laser on the side here. that means I have no strength, not the same as the other procedures. So that's why angle is the first thing when you talk about penetrations. We need to keep a good angle, right? This is not the only thing. Of course, we need to adjust the power, the traveling speed, and another tricks that we have that, if you're familiar again with the light weld, is the wobble frequency and wobble length. We're gonna dive into that to explain a little bit better how that works. Now here I have a video that I would like to show you as a simulation of laser weld. This simulation is interesting because we can cover issues that you may have experienced in the past, or to avoid this kind of mistakes, it's important to pay attention in the detail of this video. Oh, it's a 5-second video. Just try to see it here. So this shows how the laser penetrates inside the plate and pass through, and you're creating a heat affected zone, and the laser is traveling. I'm going to repeat that. You see? So first thing we realize when you see this simulation here, you see that sometimes the laser can cut and pass through, right? So see here, the laser is passing through. We don't want that. So if I don't want that, if I have too much penetration, I can control that with power. I can use less power, or I can control with the wobble. I can have the laser moving faster or slower, or not so much, the traveling not so much, not traveling larger, like in this case, so I can adapt the penetration. But then one thing here I would like to explain how that works, because sometimes we have customers, or maybe you know someone that said to you that laser weld can have porosity inside, and why that is happening. If you see here inside at the bottom that the material that is fusing is revolving, right? Is revolving, and maybe you can have a gas trap here, and then you create bubbles, right? So this means that you cannot have as much penetration. So if you penetrate deeper, it's gonna revolve the fused metal and it's gonna trap the gas inside there. No, that doesn't mean that this is the issue. That means that we need the laser to move, in this case, faster, right? So if you ever see something like this, or you're having a porosity inside the weld, probably is because of that. Probably the frequency that you are using is not the correct one. So, or is the frequency or the traveling speed. We need to adapt to avoid porosity. So again, if we want a deeper penetration, we need to adjust the traveling speed. If we don't adjust the traveling speed, we may have this problem. We have the penetration, but then we have also porosity, or the gas entrapment on the material. We need to adapt both, right? So if I want more penetration, let's say I want 8 millimeters deep with the light weld 2000, I need to adjust the traveling speed or the laser frequency to avoid have porosity inside my weld. Now I'm gonna show you one thing here that is very interesting, and it's something, it's not new, but it's important for us to try to adjust, and I'm gonna explain why. That is the laser compensation. What is laser compensation? So on the light weld, we have the wobble. Wobble means that the laser is moving left and right. The laser is always moving. The laser is never stationary unless we want that. But ideally, the laser is doing the wobble movement, left and right. Every time that the laser stops in one point, it needs to go back, right? So the laser moved to the left, it got to stop and change position to go to the other side. Every time the laser stops, if you have a continuous wave of power, what happens is the laser is going to penetrate deeper, and this can be an issue. So in this macro here, see this macro, we have the power compensation explained. You see that when we have no compensation, power compensation set at 0, The penetration on the weld toes goes deeper. You have the saber tooth that we call, right? So we have more penetration here. When we set the power compensation to 25%, then we equal the penetration. The penetration is equal on our material. That's what we want. Sometimes this is not critical, but it can be critical according to what you are welding. Let's say you are welding food grade stainless. This kind of situation is not interesting for you. You see on the sides, here on the left side, on the right side, that means that the laser is passing through, like the video that I showed you. The laser is passing through on the corners, on the welding toes, and then you have the contamination here if you have food grade equipment. So you don't want that. You want the penetration to be equal. So you need to drop the power on the weld toes. How you drop that? Through the power compensation. When we set the power compensation to 50%, this is the shape we have for our welding bead. And if we set the power compensation to 75%, we have minus 24% of penetration on the welding toes. Okay? So according to different products that you weld, different assemblies, it can be interesting to use the power compensation. Okay? For light weld. To start with, the power compensation is available on the 2.0 software. So maybe your machine is set to version 1 of the software, and you can upgrade that. So if you're interested, if you want to upgrade your machine to use power compensation, you can contact Spark & Co. and we can check how to upgrade the software on your machine. Let's say you have the software version 2. How can you use the power compensation then? Let me show you quick here. So this is a setting that I'm gonna try. I'm gonna weld and show different settings here, and then you can see in live how that works. This is a setting that I just made quickly that I have no power compensation, right? So if you look here on the right side, you have on the middle, you have the mode CW, that is continuous wave, that is in this case 500 watts constantly. Ramp up, ramp down, the compensation at 0. In this case, the laser is going to deliver 500 watts, doesn't matter where it is. It's going to move, delivering 500 watts. I have the wobble frequency set to 75 hertz and wobble length at 2 millimeters. So let's do a welding bead here with the 0 compensation, and then we can compare with a little bit of the compensation. So to start with, I'm going to change my camera to show you the table. Let's put a bit right. Okay, so this is a bead that I weld with no compensation. Now I'm gonna switch here on the machine to weld with compensation. As you can see, I changed the index program to user 8. It's the same amount of power, 500 watts, 75 hertz of frequency, 2 millimeters wide. But now I have 29.8 of compensation. I can clean that and set to 35% of compensation, for example. I save my setting and I can weld. So here we go. So on this side, I did 2 bead, right? First one, no compensation. You can even see a little bit more discoloration on this one and this one here. less discoloration. When we look at the other side, I don't know if you can tell on my camera, but on the sides I have the same issue that I showed you the picture. On the sides here on the welding toe, the penetration is too much, so the laser is passing through, is burning through, and here it's flush, so I know the laser is not passing through. This is what we want. We don't want that. Then you can argue, well, if I don't want that, I can just change the power. I can just lower the power. If you're welding with 500 watts, it's just changed to 400. The thing is, yes, then in this case 400 watts will not be enough the laser to pass through the welding toes, but you are losing penetration where you have the wire, or if you're just fusion, you're gonna have a lack of penetration on the middle. So you want to equalize that, to have the same amount of penetration, an equal penetration all the way. That's why power compensation is so important. Now, let's go back to the presentation and we can check other settings that are important for the penetration on laser weld. Laser power. So this is the first or the easiest one to control the amount or the depth of penetration. So at 500 watts, the same that I have here, that I did this testing, I should have 1.5, almost 1.5 millimeters of penetration. Let's say I set the machine to 300 watts. 300 watts will give me 45% less penetration. And if I increase the power to 700 watts, I'm gonna almost double the penetration, 45 or 50%, almost 50% more penetration. Of course, if you're using more power, you are adding more heat and you have more penetration. This is the easiest way to control penetration, but it's not the only way. We have another way, that is changing the wobble length. What is the wobble length? So the wobble length is how wide is the bead, or how wide the laser is moving back and forth. So according to the chart, when you put the setting from the chart on your machine, you're gonna have wobble length and wobble frequency set at 0. That doesn't mean that you don't have wobble. That means that 0 is your reference point. Is a number, a certain amount of number or a certain value that is determined by IPG through this kind of study, and they set at 0. It is a percentage for you to have a reference. So let's say in this example, the wobble length set at 0 means that I have 2 millimeters of the laser moving back and forth. When I set on my panel here to do a -5 wobble length, that means that I have 50% less. So 2 millimeters at 0, 50% less, I'm gonna have 1.5 millimeters of moving back and forth. It's just a 50% less, right? Or 1 millimeter. I'm gonna have 50% less of that first value. And it's same thing if I increase the wobble length, right? If I put at 5, I'm gonna have 50% more or 50% larger the laser moving back and forth. But this is interesting on how this affects the penetration. So if you check here with the machine set at wobble length 0, we had 1.5 millimeter of penetration and a 50% less or -5 on the panel of the light weld, you're gonna have more penetration. And if you increase the wobble length, if you put more wobble to the laser wobble more or be larger, you're gonna have less penetration. So you increase the wobble length, you decrease the penetration. If you decrease the wobble length, you increase the penetration. Pretty much like shown here on those macros, right? So sometimes we don't want to change power. Again, someone could argue, okay, but if I want more penetration, I just increase the power. Yes, but if you increase power, you also adding more heat. And for some applications, you don't want more heat because you can have more distortion, and you want to avoid distortion. In this case, you need to play with the wobble length. The wobble frequency works the same as the wobble length. So if you increase the wobble frequency or decrease the wobble frequency, you affect the penetration. How come? The laser is moving. When you increase the frequency, that means that the laser is moving faster. It doesn't have enough time at the same place. This will reduce the amount of penetration. So the wobble, it's a fine tuning that we use to control penetration and doesn't add too much heat to the part. Sometimes it's necessary, but a lot of times we can just play with the wobble. Now, one thing is interesting, focus point. How the focus point affect our weld or the penetration of weld. So if you're familiar with the head, here inside of the head of your light weld, you have a focus lens right here. So the focal position, and the red dot that you have here, the guide beam, right? So this is the distance you need to respect. So here on the presentation, when we say standard position, standard focal position, that means that you have the nozzle, this nozzle here, you have all the way inside. This is the standard position for a focus point, right? So you have an option. You can even see on the side of your nozzle or the nozzle of your light weld that you have a scale. That is to adjust focal position. Sometimes you need to adjust that. But how does affect on a proper way? Or like I just did here, horizontal welding. How does affect if I put like 4 millimeters outside? If I stick out the nozzle, how that will affect my penetration? As you can see here on the presentation, if I increase 4 millimeters or if I stick out my nozzle 4 millimeters, I'm gonna lose 30% of penetration. And if I put the nozzle inside 4 millimeters more inside the head, or if I reduce my focal position 4 millimeters, I'm also going to lose 30% of penetration, right? This is very important to respect that, okay? On a simple example like this, when we're welding on a flat position, this is not an issue. But let's say you are welding something tight, a tight corner that you cannot access easily with the nozzle. How can you adjust that? So with this scale that you have here, you can adjust the focal position to keep the same distance, right, between the point that you have here and the focal length. This is the most important thing we need to keep, is this distance here to have a good focal position, to have the proper amount of penetration. So this concludes our presentation here. Now let's go back to our questions and answers. Let's see if we have any questions that we can help you with. We'll be happy to So if you're changing, what I understand so far is that you're changing the power, reducing the power and having the same amount of penetration. That means that when you're putting your machine at the maximum, you are not reaching more, or you are not seeing any difference, right? This is what I understand. You need to change in this case, or you need to play with the frequency. You need to adjust the frequency. If we check on your recipe card, when you reach higher wattage, when we need more power, when we require more power, you need to adjust. You have a red dot here on the besides the power. And you need to adjust, if you read on the bottom, the frequency. So what that means is that you're having the penetration, or the laser is penetrating more with 2000 watt. But remember that video that I showed, that you have the revolve infusion on the bottom. So the laser is too fast, and it cannot pass through, right? So it's not passing through. So this is what you need to adjust. You need to adjust the frequency. Try that. If not, you can consult us, and we will be we'll be happy to help you.
Okay.
So this will depend on first which wire are you using. All right. So let's say you're using two old 1.6 millimeters or 116 wire, then you're gonna need to use almost double the power that you're using. So let's say you're using one wire, welding with just one wire, and you're gonna need 116 wire, you're gonna need 1000 watts. If you double the wire 116, you're probably gonna need to double the power to have the same amount of penetration. Why is that? It's because if you're using two wires to weld at the same time, you need to adjust the wobble length. You need to have a wider bead, right? So like you just showed here on the presentation, if you increase the wobble length, that means you have less penetration, and you're adding another wire, that means you're gonna have even less penetration. So because of that, you're gonna need pretty much double the amount of power to have the same amount of penetration. If this is enough, or you need that amount of penetration, it depends. It depends on the material. It depends if it is aluminum, if it is mild steel, if it is stainless. But a rule that I usually use is that for 116 wire. 045 wire, if you're welding with two 045 wire, 50% more power would be enough to adjust. My start point is always the chart, right? So the chart that comes with the light weld, it is made on a flat position. So this is a good start point, right? I weld these two examples here with 500 watts because this is what the chart told me to do. If you're welding on a horizontal position, if you want this amount of penetration, use this amount of power. So I use the chart as my base. Of course, sometimes you need to adjust. I can weld faster or I can weld slower. Then I can adjust the amount of power based on that. But the chart is my start point.
And does the 1500 XR have power compensation?
Yeah. All the machines, all light welds, they have power compensation. Again, but the power compensation is only available on the version 2 of the software. We have the version 2 of the software for all the models, all the light welds. Doesn't matter which light weld you have, you can have the version 2 of the software. Maybe, depending on where or when you bought your machine, you have the version 1 of the software. Then you need to check with us if it is possible for you to do your own upgrade or not. Sometimes, some machines, depends on the year that the machine was made, we need to update the machine here at Spark because it's two boards. You have two boards. There's some technical issues that the user cannot do it by themselves, but it's definitely possible to upgrade any light weld. All right, thank you very much for everyone that watched here this first webinar. The next one I would like to say in advance that will be a very interesting one that will be about maintenance. How to keep your light weld, how to keep in the proper way, how to do the maintenance on the heads, how to do the maintenance on the light weld, how to check all the optical elements, how to proper clean lenses. This we will all explain on the next webinar, and I hope I can see you here again one more time. So keep tuned if you want to watch the next webinar. Thank you very much and have a nice day.